All right, so let's find out what nearly $1,400 of glass and light actually buys you in the world of professional broadcasting.
Yeah.
Today, we're doing a deep dive into the Thor Broadcast F-SDI-3G-B-Tx RX kit. And our mission really is to figure out why this thing costs so much and what separates it from, a standard video converter you might find online.
Well, that price tag is essentially, it's an insurance policy.
Mm-hmm.
It's for guaranteed, reliable packet delivery.
Okay.
This kit is all about the serious transport of SDI signals, SD, HD, 3G-SDI. I mean, this is the bedrock of professional video.
So ensuring the signal stays perfect over long distances.
Exactly.
Okay, so let's unpack this a bit. The first thing that really stands out to me is the architecture.
The pure hardware design.
Yeah, the sources highlight that it's pure hardware. And that's a huge deal because it means zero compression,
Right.
which gives you much better throughput and avoids the latency you get with software-based processors.
But what's really fascinating here is the focus on speed. They talk about zero delay transmission.
Which, is that actually possible? Zero delay?
Well, the spec sheet clarifies it a bit. It's about a 1 millisecond delay. But for a professional broadcast environment,
That's basically zero.
exactly.
Right.
It's so fast, it's considered real time. Speed is absolutely non-negotiable in that world.
I also saw it's compliant with SMPTE 424M. Now, that's obviously important, but what does that guarantee when the signal gets, messy? Like, how does it handle something they call pathological signals?
That's a great question. So connecting this to the bigger picture, that 424M compliance means it plays nice with all other high-end broadcast gear anywhere in the world.
Interoperability.
Right. And handling pathological signals. That means the device is built to manage maximum stress. We can handle these bizarre, unpredictable data patterns that are designed to break things.
So it guarantees consistent throughput no matter how weird the data stream gets.
It's non-negotiable signal reliability.
This is where it gets really interesting for me. The range and efficiency? It can do 20 kilometers without repeaters. 20. On a single mode, single fiber.
Just one strand of glass.
What does a 20-kilometer run actually look like? Is that like a giant stadium or...
Think bigger. Think an entire university campus or live remote feeds from miles away across rough terrain. It's significant infrastructure.
Wow.
And this raises the really important question. How does it get bidirectional video over that one single fiber?
Yeah, how does it do that?
The answer is a technology called optical CWDM. That's coarse wavelengths division multiplexing.
Okay.
It basically uses different colors or wavelengths of light to send signals in both directions at the same time, instantly. Cuts down on complexity, cost, everything.
And just to put a number on it, the max bit rate is what, almost 3 gigs a second?
It handles up to 2.97 GBPs, yeah.
And looking at the physical unit itself, it's industrial grade, it's modular, and I love this part. It's plug and play.
Totally. No setup needed.
You just take it out of the box and it works.
And it works almost anywhere. The operating environment is, it's extreme.
How extreme?
It has an APC circuit that's automatic power control to keep the laser output stable. So the unit can operate from negative 20 Celsius all the way up to 75 Celsius.
So freezing cold to scorching hot.
It's built like a tank.
So what this all really means for you is that this kit isn't for your average setup. It's for non-stop high-stakes video feeds that simply cannot fail. We've seen that the pure hardware, that incredible 20-kilometer range on a single fiber, and that CWDM tech, that's what you're paying for. That's true broadcast quality.
Right. And I'll leave you with a final thought on that. The MTBF, the mean time between failures, is rated at over 100,000 hours.
That's over 11 years of continuous operation.
Exactly. So think about this. What kind of critical high-stakes infrastructure relies on that level of guaranteed uptime? What systems out there can tolerate absolutely zero downtime? That's something to mull over.